So I'm here back again to talk about Bacalhau, a platform to bring to compute to data. As I mentioned earlier, Bacalhau, we hope, is just one of many platforms, many different specifications and things like that. But we've made some terrific progress, and I'd love to show what we have today. So that's us. That's the fish. By the way, everyone knows why it's called Bacalhau. Does anyone know why it's called Bacalhau? Anyone? So it's like we were in Portugal last year when we were thinking it up. Compute over data, COD, Bacalhau. That's the joke. And the question is, we had at that time was, can we build a decentralized system that was built for decentralized compute, right? Start with decentralized compute first and work from there. So in February, when we started, we set ourselves a goal for April to have a Computer over Data Summit and to set some of the goals you see here. Very small, very gradual. Interestingly, I was one of the first PMs on Kubernetes, and I led it for several years. And this is much bigger than we had as our first one. Kubernetes gated at 50 nodes at the start, interestingly. A little data point for you. So this was actually more substantial than that. But we said, with 8 weeks, we feel like this is something we can do as a proof of concept. So we started, first line of code written. I think I wrote it. I don't know. It was like Kai, me, or Luke. Somebody wrote it. Somebody checked it in. It was, I think, CI. Who knows? Anyhow, you can go check the repo. It's there. And the first Compute over Data Summit was just 8 weeks later. And we did really well. I was shocked, actually. Luke and Kai get on stage. They demoed it. They demoed our interfaces and things like that. I'll give us yellows for 5.9s. I think we didn't have quite enough monitoring things at the time. And deterministic, certainly it was there of a proof of concept, but there was a lot to desire. But the rest of it did work. Scheduling and CIDs and public data and so on. So then we said, okay, let's present this to everyone. We got really good feedback. You can see there, that's our first teeny little group getting together, being excited. And the number one question was like, okay, you're practically done, right? When is it coming? So we set ourselves a big, hairy, audacious goal. And that goal is what you see here, right? We wanted to get to 1,000 nodes, provably 1,000 nodes. We don't actually need 1,000 nodes running. Being able to run, not just schedule 10,000 jobs, be able to process basically unlimited amount of data across many nodes, job success rate, malicious nodes, or handling malicious nodes, DAGs, and so on and so forth. You can see those there. And that's a lot. That's a lot to take on for October. But we are not, if nothing, not ambitious. So in June 1, we launched alpha to production. No gates, no anything. You could go out there, download a client, and have at it. In August, we added Filecoin and estuary support. And in September, right at the beginning of September, we were able to add native WASM and GPUs. So we went back and looked at this, and we said, okay, we're actually at where we wanted to be timeline-wise. We actually were about a month early. And, some reds here, no question. Very, very large file processing we weren't able to do. We didn't do DAGs or malicious nodes at the time, and no reputation system to speak of. But we did succeed in a bunch of things. You can see those there. But along the way, we had listened to a bunch of people from the ecosystem who were already giving us feedback, who were always saying, hey, this would be great. If you could do this, can you do it? And you can see this list on the right here. So everything you see on the right there was not in the original spec, yet it is what we delivered. GPUs, HTTP downloads, open telemetry, you name it. Huge performance wins, huge examinations of locks and mutexes and things like that. So we were really pleased with that, and we were moving forward. So, which brings us to today, where we are proud to announce our beta. Now, obviously, it is beta. There will still be API movement. Oh, thank you. So, there will still be movement in the API and things like that, but we really are taking on SLA and things like that. We want to have uptime. We have canaries. We have all sorts of things that we want to nail. And I'll talk about our path to getting to 1.0 and things like that at the end. And again, it goes back to our original vision. Can we deliver simple, low-cost, distributed first tools and unlock new ecosystems and collaboration? And if we do that, you'll get simplified execution, you'll get huge performance wins over even potentially a lot of existing systems today, and you'll launch a new collaborative scientific community. And one of the things when I say simple is really meeting people where we are. And so I went through this thought experiment. I gave this slide back in April, and I said, look, this is what people are using today. This is Microsoft's research. They published it. They use 158 different tools, 68 different tools. Oh, 59, sorry. Different tools. It's just an enormous amount. And if you map to what we can support today, it's actually not bad. I don't know, call it 50-50. And some of these we'll never support. Like, we're not going to support PowerPoint. Sorry. Well, who knows? Maybe you could script PowerPoint. I have no idea. We do support Windows, by the way, so maybe. But, and some are yellow. Like, yeah, you can throw it in a container. Is that really doing it? But the point is that it's not that bad, right? You can throw a Jupyter notebook in. You can throw Python, so on and so forth. Not terrible. But I think this is really a mission. Like, how little can we have data scientists do and take advantage of all these things? So you may be asking, what can I do with it today? And so let's show right here on stage. So I'm going to start with a very simple one, right? One thing that's kind of weird about Filecoin, no matter how awesome and like widespread, universal it is, it's actually kind of hard to upload your data. Not with Bacalhau. This is it. Seriously. Can you abuse this to your heart's content? Well, obviously. So let's go. I don't know if you've seen, there is can you see this here? Yeah, good. So I'm a cheese fan, so I'm going to search for some cheese. Wensleydale. Cheese. I'm going to be very responsible here and use only a Creative Commons one because I want to be a good citizen to the world. Oop. Okay. And I'm going to grab this image of Wensleydale cheese here, which is on the Creative Commons thing. I'm going to find this. I'm going to go over here. Oops. I'm going to enter it as a URL. And now I'm going to execute this command. Sorry. Now, what you see here, it says Bacalhau Docker run. I give it an input URL. I give it a container that we offer called the uploader, and I return. That's it. I've taken an image that was out there in the world. It is now running. It is finding it, downloading it, copying it over to Bacalhau. Presto, we're done. And now I take this. I say, go get it for me. I was a little bit nervous. It's not that we don't support it, just oftentimes the handshake to actually getting the thing. Oh, wow, fantastic. I'm going to go grab this. It downloaded it into this handy folder here. Combined results, outputs, and there we are, Wensleydale cheese, presto. That was uploaded, put on Estuary, put on Filecoin, downloaded through Bacalhau, and by the way, not just there, right? I can go straight up to any other gateway and get it. Presto, magic. And it's cheese, which I'm always a fan of. So that's not abuse. That's just nothing. So I don't know if you've seen, for example, they have these great data sets out there in the world. This, in fact, is NOAA's geostationary orbit, right? There's a lot of images in that. In fact, if you open up the buckets, you can see like hundreds, thousands of images. I mean, it'd be a shame if someone didn't grab every single URL and throw it in a, simple loop and execute the hell out of that. So now, every UUID you see here is being uploaded to Filecoin as we speak. So that's pretty easy, wouldn't you say? That's it. €1,000. So not so bad. So there you go. Abuse away. And by the way, I should point out there, you have a QR code in the upper right corner. Every one of those QR codes are different, and they all link to our public documentation where you can see stuff. So, all right, now I have a bunch of data on Filecoin. What can I do with it? Well, I could run some Python. There you go. Upper right, you can run it right there in line. Middle, you can run a complex thing where you might need to import things. Unfortunately, we don't support, you can, we'll get to how you do it in a minute. You can't do requirements and things like that in this format, but you can, anything that's native to Python you could do. Or if you do need to do something complicated, you can see down there in the lower left, you can actually put your entire script on Filecoin using the same URL that I showed earlier, and it'll run just fine. Okay, how about R? R is pretty popular data science. We got R. There you go. And you're like, all right, fine. Hello world. Let's get to the good stuff. All right. So now we're going to start to get more complicated. Pandas, again, huge data processing thing, super easy or super powerful. In this case, I mentioned about like using multiple files simultaneously. How would you do that? Well, there you go. So you can see in that tree, I have both a CSV reader and transactions that I'm going to want to process. I'm going to add both of those into a IPFS, get CIDs back. And then down below, you can see I'm going to mount those CIDs into a folder. You can see there I can name the folder, working directory files. I run my pandas container, and then I run the script that I was doing, and it's able to mount in all the files that I had named earlier into that single folder and just execute it like it was on my local machine, right? There you go. This one's insane, but it's so good. I love it. Let's say you have a Parquet file. Who knows DuckDB? Anyone? All right, not a lot of people. So it's this wonderful thing that basically will allow you to mount in columnar databases or columnar files at all and give you full SQL functionality against it. So in this case, you're going to mount in the CID of a Parquet file that I want and start DuckDB and execute arbitrary SQL against it. Then it shuts it down, tears it down, and destroys it. But now I get full SQL against any Parquet file in the world without installing anything. That's pretty sweet. Who knows what YOLO is? YOLO is the #1 object detection thing for images. You can see here. We're just going to mount in YOLO and run that. Presto, YOLO. And you do that over thousands of images if you want. And one thing I want to show about this architecture here is the YOLO container is actually quite small because we are mounting in the weights from IPFS. Meaning you don't have to download all these various things in order to do it, especially if your containers are quite large. That makes it extremely portable. And because we schedule to where the data already is, spin up time for this should be quite quick as well. And if they're not available and you want more CPUs, you're able to do that. How about go figure out the next protein? You can do AlphaFold. Not too bad. All right. You're saying lame. You're demanding. Stable diffusion. Let's get to it, baby. All right, so if you are silly, like me, you like cheese, and you really want to be silly about this. So what we're going to do is here, we do have a stable diffusion container. We have GPUs on the network. Let's abuse this. I like cheeses, so I downloaded 1,000 cheeses. You can see them here. I wanted to have a verb, just to like say the cheese is going to do something. I don't know, who knows what, right? Stable diffusion, you'll figure it out. I merged them together into a bunch of sentences. Cheese, cheddar, cloth-bound survey, now Oklahoma City would go blah, 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 blah. Who knows? Stable diffusion will figure it out. And I executed 1,000 of them. So there you go. Running on the Bacalhau network. We're going to pop over, and here you go. Once per second, it will go out to the network and grab stable diffusion doing something silly with that sentence. There you go. I mean, I have done a lot of demos and led up to things in my life. This probably was some of the wildest demos. I was like, what else can I do? Oh, here we go. Some of them are crazy. Like, how do they, like, look at that. That looks like a real picture. Man, stable diffusion is amazing. And some of them are just, what is she doing? She's running with cheese? I have no idea. All right. All right, back to the demo. So, like I said, you can go get that. We have that published. I will say, by the way, you run on CPUs, be expected to wait. That's fine. There aren't that many GPUs in the network. We would love you all to join and participate in GPUs, but there you go. Seriously. And, here you go. Lots more stuff that we did. Some real nightmare fuel out there, by the way. Still, well, geez, man, you guys are demanding. It's WASM time. So I took that, actually it wasn't me, it was my colleague, took that Stable Diffusion demo here. We generated a bunch of superhero dogs, and we ran those. Oops, sorry. Here's the code. Again, it's all hosted out there. Very simple. It takes the existing image that's already out on Stable Diffusion, or on IPFS, and it runs in WASM a transformer to convert that into just, I don't know, take your random image conversion tool. Here, we're going to run that over here to the side. I will zip forward here. There are my superhero dogs generated by Stable Diffusion, and now we're going to apply a filter against them, and you can see those there, right? Again, in WASM, executed on the network. I didn't have to think about anything. I just ran my code. And let me just break this down for you for 1 second, right? You write your app, whatever it might be. You use, in this case, cargo to target your WASM runtime, and that's it. You're done. We upload the job to Bacalhau, find an appropriate node, mount it in IPFS, mount the data, in from IPFS, run the job, and write the results for you. Again, could not be simpler. Just stay focused on what you do great, what every data scientist does great, and go from there. We promise. And even further, you don't even have to install it. Every one of these examples has a notebook on Colab. You can just go click it, run it right there in the browser. Kind of. So our motto is, if you can contain it and you can compile it to WASM, you can run it. Mostly because we don't have any networking for now. Networking is a huge security flaw or security surface area, and we want to be very, very sensitive about that. And you might say these seem like science projects. These seem like Dave having a good time with demo. Too much fun with demo, probably, but there you go. I want real world, and we are very happy to announce many real world partners that we're launching. A few are listed here. So first, we're proud to announce we will be partnering with the Caltech High Energy Physics Lab to do work with their Large Hadron Collider CERN processing. We will also be partnering with LabDAO to accelerate scientific progress, enabling people to use our compute or use the compute framework to deploy and run. We will be partnering with the City of Las Vegas and Blocks to launch CCTV for internal processing and other things like that. That data is going to be available and online. This was a really interesting one because they have requirements on locality and where that can be deployed, and you can deploy the Bacalhau network to your own private network if appropriate. Again, our feeling is that this is even easier than a lot of the big data platforms today. They're just far more valuable and easier to engage with than having to set up Hadoop, Spark, so on. I don't want to take anything away from those platforms, but we solve a different purpose. We're doing a lot simpler things in a sharded, decentralized first way. When you get to the end of it, then sure, engage with these other things that are more appropriate for things like streams. We're also proud to be partnering with the Boeing project. For those that don't know, one of the earliest broad-scale end-user contributions, SETI at home, climate prediction, Rosetta Bio, things like that. We're going to be partnering with them as well. And finally, you'll hear about WeatherXM later today. We're very excited to be partnering with them. They're collecting weather data from all over the world, and we're going to help them process and run their models on it. So those are all launching today or very soon. Certainly the announcements today, but very soon we'll be talking about them and what they're doing publicly. I talked about earlier the compute over data and what we're trying to achieve via compute over data. You can see that here. Our hope is that Bacalhau sits, right at the center of it. And if we're not, we really want to get there. So we are very serious about being a very open, very extensible platform, not just for us. We want to also enable other platforms that want access to compute over Filecoin compute over data, helping them achieve that. So what's next? I'm going to walk through a little bit of our roadmap over the next year or so. When we think about it, we really think about breaking it down into two major categories. First, from the end user side, you have people who are actually wanting to run jobs on it. And from the compute provider side, those are people who want to enrich their storage provider deployments or potentially earn incentive. Obviously, we don't have incentives yet. We're working on that. But there's like making the storage they're already hosting on Filecoin and IPFS richer, since we plug in directly. All you have to do is mount it in, and we can run it. In M1 in December, we're going to be powered by Phil Plus. We're going to make significant improvements on performance, reliability. We're also going to launch our dashboard, which we're really excited about. So you'll be able to look across the entire network, see jobs, see your jobs, and things like that. In March, we will finalize our support for WASM. What you see here is, I would call it beta quality, which is fine. We are at beta. We're going to improve reliability, particularly in transport, making sure your jobs are running to completion, that the network handles that. We also are very serious about improving the developer experience. We want to make that loop of executing jobs very, very straightforward. So you can, on your local laptop, simulate what it's like to run a full Bacalhau network, and then when you move it to the network, you can be very certain that you're getting exactly what you ran locally. We're also planning on launching our API client to 1.0. Means API stability. Building on it will be much more predictable. And if nothing else, we're going to have versioning. We do have API versioning right now, but we're going to be better about enforcing it and having backwards compatibility per whatever we decide as a community. Also, we're going to have our grant program on our Bacalhau season beginning. In June, we're again going to work to improve our developer experiences, particularly around some of the most difficult concepts for decentralized systems, or distributed execution today, MapReduce, sharding, things like that. We already do support very rich sharding today, but not over single files, and which can be a problem. If you have a very large file, how do we split it up? How do we make it easy? Also, finalizing support for DAGs, full DAGs, though we already do have some work on that initially. I think we could do a lot more. Federated reads, so if you have a large file that crosses many machines, how do you read from them all simultaneously? How do you join them and execute them? And rich local client. And finally, consensus and verification of deterministic jobs in September, website for data, no code type experiences, those kind of things. On the compute provider side, we're going to have Phil Plus. Our plan right now is to look at, if you run the compute job, you will get first rights to bid on the Phil Plus deal. So if you run it on a Phil Plus, you'll be able to get Phil Plus on the other side. Obviously, that's a huge incentive to anyone wanting to participate in that program. In March, looking at the unified control plane. So if you have many nodes, being able to look at them, graph them, understand what's going on, understand who's running what on your machines. You can already do that right now, but giving people a much cleaner way to interact with that. Multiple executor support, we talked about that, and our server API reaches 1.0. In June of 2023, additional deal engines. Like I said, we already support Estuary. We want to add many more. We're also going to support for much more malicious network attacks, Byzantine fault tolerance up to 1/3. And then finally, our end of the year goal is that anyone can be a compute provider. I was, incredibly inspired by AlphaFold and SETI at home and things like that. I want to have everyone, on this very powerful machine that most of the day does nothing, be able to participate in the Bacalhau network and potentially, advance humanity. And with that, that's it. Oop. No more cheese. Any questions?
For the server M3, how are you approaching the Byzantine fault tolerance? And is that going to be an FVM integration or?
We are speccing it out as we speak.
Awesome.
We are talking very closely with the FVM team. Obviously, they provide you a layer of consensus immediately, and so it's very optimistic that we're hopeful that we're able to do it. I think if I was to place my bets, I think that integration with them would be quite likely. But we don't want to have them need to take a dependency on us. If they're have other priorities, then I want to make sure that they're able to execute according to their schedule. But over time, I'd be very surprised if we weren't closely integrated.
Sick. Thank you.
Hi, great talk. Also love cheese. Perfect. So my question is, do Bacalhau nodes communicate? So what I mean is, so I submit a job. A job has 2 computations, let's say. So can 2 Bacalhau nodes coordinate those computations? Is that something that you're looking forward or not?
So there's a subtle thing there, and I'm going to break it apart, if I might. The first is DAGs, a DAG, directed acyclic graph, right? Like, how do you start at one place and get to another place along many steps that may, fan in, fan out, have conditionals, all that kind of stuff. We plan on supporting that. We are actually already working on that as we speak, so that you can submit to the network your DAG, and we will figure out how to execute it, whether or not it's on a single node, whether or not it's over a series of nodes with intermediate steps, things like that. We are working on that. However, the networking thing, we do not support right now because the attack surface is too high today. Every node has no networking. It's very disappointing, but it is true. No networking, meaning after you start your job, you saw there that I could mount in from a URL, anything, but that is before the job begins. Once the job begins, that's it. So no, like, for example, downloading from PyPy and, your requirements. You got to build that into the container or have it in a, already mounted on IPFS. No worker parameters, master nodes for a 3-tier TensorFlow deployment or something like that, right? Unfortunately, it's just too big an opportunity for like attack, and it also hurts the ability to do determinism. That said, we have a lot of really good ideas how to get around that in very isolated ways. We just haven't gotten there yet. As you saw on the roadmap, our back of the envelope guess is September of 2023, which is a long time. I think we can come up with intermediate steps that might get you there. But it's the reality for truly treating this like a general network. That's probably when it is.
I'm really interested in the reputation structure you're
Yeah.
thinking about. I'm wondering if you can talk a little bit about it.
Still very much in the spec phase. We have a lot of thoughts. I think that we're exploring just about every model that is out there, whether or not it's having referees that oversee things until we bootstrap a reputation system, historical reputation. Once things, you could also imagine, generalized consensus where you deploy this. It's actually quite trivial to deploy to 10 jobs concurrently, and then at the end evaluate if all the things equate to each other. You could do that too, or some number of them equate to each other. But I will say, I will be honest, it is very early thinking there. We're always looking to plug someone else in. We would love not to invent it ourselves.
Awesome, thank you.
Any other questions? I think I have time for one more.
Sorry, a lot
Yeah,
of
go ahead.
questions. Big fan. Do you guys support harnessing multi-CPU or GPU hardware stuff already, or where does that fit into the
We do.
roadmap?
It
Cool.
is fully supported. So it's already it's basically just assume anything Docker can do, we can do.
Okay.
So absolutely multi-thread, multi-GPU, things like that. We don't have any multi-GPU machines on the network, so you got to add your own, but or encourage people to add their own. But yes.
Awesome. Thank you.
One more.
What about TPUs? Do you have a plan for that?
No plan. I have no idea what
I mean, when
Google's.
eventually storage providers will, I don't know, sometime
Well,
in the future.
to be
have-
clear, again, we are gated on Docker for now. So if you can give me a Docker container that runs TPUs and then mount a machine that supports TPUs, there's absolutely no reason you couldn't do it. There was one right here. And I promise that's the last one. Is Juan here? Okay.
I do a lot of work with ecological data, like in a forest. How do you imagine this could work for edge computing and edge storage and those kind of environments?
Edge. Well, as I said in the first talk, this is designed specifically for that, right? So, like I said, if you can contain it, you can run it. So what I would say is, depending on how low power your edge is, this is an ideal network for you. what you would do is, at the edge, you would collect your data, you would write it to some file store, you'd upload it to IPFS, which eventually would propagate to the rest of the network based on whatever your requirements, or not at all. The Bacalhau node would run on that same edge. This is a very lightweight deployment, just sit there and run. And you would request to the network and select, I want it to run against things that have this data or in this particular machine profile or my private signaling, right, label. I want it only to run in whatever, Yosemite on whatever these devices. Again, we're looking through a lot of the node selection stuff right now. There's a lot of flexibility, and we'd love to get your specific requirements. But the net is you would take that job, either raw compiled code, WASM, or your container. It would push it down to that edge. It would run it locally, and then it would give you only the derivative. And so in many ways, this is hugely valuable for that, because those things on whatever 256 kilobit connections that connect once a day, you don't want to be like interacting with them in some long-standing way that requires like this huge long uptime. You want it to trickle back the results and trickle back just what you need. So if you had said like, hey, 98% of the day there's no data and then 2% is, normally today you would have to push all that back to the server in order to figure out there was 98% of it was worthless. If you could run a simple filter job on the edge where it is right now and then push back only to 2%, that'd be a huge win. Okay.
Sounds good.
That is my time. So thank you so much.